The last of Chapter 8 is actually going to deal with ecological succession. The word succession by itself means change, so it's basically change in our community, which is actually very natural. If you think about the state of Hawaii, Hawaii was not always lush and green as it is right now. It actually started out as bare rock, of course, from volcanic activity. By the way, Hawaii is a hot spot, kind of a weak part of our ocean floor released, and of course magma released, and now it's a phenomenal vacation location. But if you take a look at it, it started out like on this picture to the far left, exposed rock, and then it just grew from there into a very nice tropical rainforest. So let's go through that process. Again, succession means change. Primary succession is the gradual establishment of biotic community on lifeless ground. Take a look at that rock. Like in Hawaii, at one time, what had to happen is probably washing ashore via the ocean or even seeds through the air. Those spores, those seeds landed on that bare rock and eventually started growing. There's actually lichen moss, which is known to secrete acid, can actually break down that rock into soil components. This does not happen overnight, of course. This takes millions of years. So where does primary succession? Think of primary succession. There's going to be primary and secondary. Primary is starting from bare rock. It could be from a retreating glacier that happened around the region we live in the great state of Wisconsin here. And what happened was all of our plant life had to be reestablished at one time because those glaciers carved right down to bare rock and then as retreated kind of deposited soil and nutrients back into it. Fresh lava, parking lot. If you think about a parking lot, maybe around this region what happens is business close, and what's going to eventually happen is little plants start growing through the cracks. Those first species that land in an environment like this are actually called pioneer species. So think of pioneer as the first, like the pioneer of the United States. There's different stages of this primary succession. There's early successional plants. They're the tiny ones. They're the things like lichen mosses. Then we get plants that are annuals. Annuals are plants that grow every year, kind of like grasses. And then we'll get small perennial grasses that actually come back year after year after year, so a little bit different type. And then we get things like ferns, and it just goes from there. We get mid-successional plants, so kind of midstream plants that are a little bit bigger, maybe herbs, taller grasses. Low shrubs start growing, again, millions of years for this to occur. Then we'll get late successional plant species, which are plants that can tolerate shade and trees. So eventually what happens is that we get those big trees like you can see on the lower right picture, and then we get plants that can actually grow below those. Another way to look at this succession is actually secondary succession. So we just did primary. Secondary succession is succession that starts with nutrients, so it's much quicker. If you take a look at the picture here, think of it this way. Outside of school here we have a field, and if we let that field just go without cutting the grass or anything, stuff is going to grow there really quick. Or if we took our environmental pond and actually cut it down or burned it down, actually returning nutrients back to the ground, grass is going to grow again really quick, and it's going to really take off much faster than primary succession. It's literally going to start growing probably the next day. So secondary succession is deemed fast, develops in places with existing soil or even like a bottom aquatic region. So we can talk about lakes or rivers with this too. So if everything, all the nutrients are there, and you can see the picture on the bottom page where there's somebody farming, of course old school farming, what's happening is that he's plowing that up. Stuff's going to start growing right away. All those nutrients are there. This could occur with natural disasters such as forest fires. Forest fires are very natural. If you go out to the western part of the United States, into Colorado and Arizona, parts of Texas, of course, and California, those wildfires kind of exist naturally for a reason. A lot of times they have to stimulate plants to grow, such as prairie grasses and things like jack pine trees, which need fire to singe their actually pine cones in order for them to start growing. Deforestation, cutting down a forest, stuff is going to regrow right away. Clear cutting is something we're going to talk about down the road. Clear cutting is actually cutting down an entire forest, everything down, but stuff, then that allows new stuff to grow. Abandoned farmlands, polluted streams. Polluted streams particularly because streams are moving water, and that's going to actually rejuvenate. Just a couple characteristics, a key chart here, 8.1. Ecosystem structure, if we start at the top left, plant size tends to start out very small in early successional stage and then get larger. Species diversity, because we don't have a lot of plant life, we don't have a lot of NPP, it's going to be very low and then get higher from there. Tropic structure, mainly producers, some decomposers in here, but eventually when we get late successional stage, it's going to be a mixture of producers, consumers, decomposers, and everything is just going to expand from here. If you take a look at the bottom ecosystem function, originally the biomass and net primary productivity, biomass is going to be low to start and then high eventually. Net primary productivity is actually going to start pretty high because there's not a lot of competition for plants, not a lot of animals eating them, so it's going to start out pretty high and then maybe get a little lower eventually down the road. Food chains, food webs are going to start out simply and then get more complex, and it just goes from there. Climax community is a matured community. You can see that. I would actually say Elm Grove is actually very much a climax community too, with their big elm trees. Very stable stage, deemed the balance of nature, everything's existing properly. We've got lots of complex ecosystems going on here, lots of plants and animals living like this. View of ecological succession, basically it's natural, leave it alone. We should just let nature do as it does anyway. It's a very orderly sequence, each stage leads to the next. Disturbances in nature, as I said, fire, drought, mining, plowing, climate change can set succession back. So we really shouldn't purposely do those things. Like mining, obviously, we'll talk down the road about mountaintop removal, like in the Virginias, which is terrible. Climate change, too, is going to screw up all the succession. But, you know, terrible to say because people lose their homes, but that fire is natural out west, so maybe we should just let it go. Nature tends to rebound very. Nature takes care of nature. A couple of very key words that affect succession. First of all, facilitation. If you facilitate something, that means you make it better. One species makes an area of land suitable for another species, so you facilitate an area for another species to come in. For example, the lichen moss that comes in and converts that lava into soil facilitates that region, makes it better for other species. Inhibition, inhibit means to slow down. Early species limit later species. Plants may release toxins. Pine trees, generally things do not grow underneath them except the darn garlic mustard. But anyway, what happens is pine trees are, the needles are very acidic, and when they fall, they inhibit other things from growing underneath them. Tolerance, if you tolerate somebody, you accept them, and you have a little tolerance to their behavior, for example. Later species are unaffected by earlier species, so maybe a plant somehow tried to inhibit other species from growing there, but those new species can tolerate and live. Intermediate disturbance hypothesis, the idea that communities experience frequent moderate disturbances have the greatest biodiversity. That is true. We see that around here. When maybe a tornado goes through central Wisconsin, for example, that community is actually going to rebound quickly. It actually wipes out maybe some of the mature trees and allows some young trees to actually grow. Communities are in continuous change, not equilibrium. What that means, kind of like the idea of evolution, nothing stops. Things are continually renewing, and that's a good thing for our systems. Ecological stability, complexity, and systems 8.6. All systems are constantly changing, as I just said, responding to environmental conditions. A couple other keywords: inertia or persistence. In the world of physics, inertia is the ability to just keep going and going and going. Ability of a system to resist being altered. Around here, our forests, actually, we do have tornadoes go through, which wipe out things, but we also have high winds. High winds do not necessarily knock all trees down. Yes, it'll wipe out some of the weak, but it does not eliminate everything. Constancy, ability of a system to keep its numbers within resource limits, so it's constant. A forest, for example, is constant. It constantly has trees. It's constantly got good soil. Those are good examples. Resilience is the ability of a living system to repair damage. Temperate deciduous forest we live is very resilient. If we get a damaging tornado, for example, or forest fire that actually comes through, we can rebound very quickly because we've got very good nutrients in our soil. The tropical rainforest, not so much, because they don't have much nutrient in their soil, which we'll talk about when we talk soil down the road. Tundra does not have very good resilience because it doesn't have, again, good nutrients in the soil because it's got very cold, which doesn't, and not much when a plant dies, it does not decompose very quickly. So we don't get a lot of nutrients returned back to the soil, so things do not grow there. Last thing, which we talked about before, little chihuahua, better safe than sorry. Let's strap a little life jacket on that guy if he's going to go out near the water. We don't know if he's going to jump in the water or not, but hey, let's be safe. When an ecosystem is deemed threatened, stop the negative effects. This is the whole premise behind things like deforestation. Stop it. We need nature to let nature take control. That's it for Chapter 8, kids.